Awesome. So thank you everyone for sticking with us. We now get to do our Q&A. So I'll be welcoming our speakers back to the stage for this question. And throughout the event, we've curated some of the top questions based on your upvoting. And for those of you in the audience, if you have additional questions, please post in the Q&A and continue to upvote. We will be taking a few questions live. So if you want to come up to the stage, raise your hand via the Zoom feature, and our team will DM you with further instructions. Awesome. So please join me now in welcoming our speakers from the summit. We have Alex Ratner, our Snorkel CEO. We can see here Chris Glaze, Staff Research Scientist at Snorkel. Alex Taylor, the Global Head of Emerging Technology at QBE Ventures. Chung Nguyen, Applied Research Scientist at Snorkel. Fred Sala, Assistant Professor of Computer Science at University of Wisconsin-Madison. And Huang Tran, Applied Research Scientist at Snorkel. I think I got all of you here. So welcome to the panel. This is one of the most fun parts, and we will start out with a question about use cases. So this is from Xian Zhu for Alex Ratner. What are some good B2B use cases you've seen so far with AI, particularly with LLMs?
Awesome. Maybe I'll cede some of my time to the other panelists and to Alex, the other Alex here, for the insurance specific perspective. But there's so many, so I won't go into specifics. I think the quick thing I'll say is it kind of goes back to one slide that I showed that I like to use as a heuristic, which is this idea that think about how complex and unique is the data, and then how accurate the model needs to be. And I think there are amazing applications in all parts of that space. I guess I'm kind of answering a different question, but I think the low-hanging fruit where we're seeing this kind of out of the box with a little bit of prompting work is often these settings where you have a lot of data on the internet, and there's a low accuracy bar to hit, or there's not even quite a metric, or there's a human in the loop, so it's really just an assistant. So what I would say there is, like, some of the low-hanging fruit actually seems really hard. But if you think on those axes, it actually is a little easier, like coding. It's a tremendously difficult problem, but you can kind of think in that perspective. There's tons of data on the internet. It's a very universal language, most code, and it's mostly as a co-pilot. So it's just suggesting to a human. It doesn't need to be 100% accurate. You don't even know what that means. Actually, we're seeing now that's one of the use cases that kind of just works. I mean, a huge amount of engineering effort behind the scenes, but so I think about, when you're thinking about low-hanging fruit, like what can fit into that mold? And then there's the whole wide open space as we move into more advanced methods of fine-tuning and data development and model development that then, go beyond that. And then that all just depends on, do you have a good measure of success, and do you have good data to tune to that? But that's a very high-level answer. I don't know, Alex, if you had any thoughts from your domain.
There's two thoughts that I'd add to that, and one of those on model accuracy is it's fascinating to see how successful the academic research and applied academic research into reducing the hallucinatory effect has been over the last 18 months. And obviously GPT-2, 3, 3.5 even were very heavily criticized for this hallucination, that people suddenly realized existed. Those of us in the machine learning field understands what it actually is. But the reduction of that, particularly in the leaderboard models, a lot of people have been fine-tuning to prevent hallucination, and that's actually dramatically increased the utility of models where accuracy is important. And it's to the point now where, just observing the way that some people are using these models as lay people, as SMEs in their domain, but not engineers, is the models are actually performing better than a human does in certain domains. There was an example I saw the other day where someone was extracting certifications and qualifications from resumes submitted, and someone had categorized as a human a certification in a particular domain, and the model actually corrected them and said, no, there's not enough specificity in this. It could be any one of these 6 certifications. You've selected this, but actually you can't make that call. And the human was sitting there, kind of having their mind blown, because for the first time they'd realized the model had pointed something out to them, which was the reverse of what they would usually see.
Very cool. Thank you for that in the trenches perspective. Our next question is actually for Alex Taylor. So you'll be back up here. And this is from Ron Jabrowski. And his question is, when working at Oracle, some of the infrastructure architects always told me we own the data. What are your thoughts on such a statement?
Yeah, and it's interesting when you consider the relationship between models, training, data, and the consumption of larger models in a B2B context. An organization like QBE to OpenAI or to Microsoft or to another vendor. Now, we're sort of seeing two camps in this space at the moment. Obviously, companies are getting very cautious over the way that they use their data or let another organization use their data to tune a model, to train a model. Because you do that once, inappropriately licensed, and you've lost it forever. Also, using any system now, the first question that a procurement division will ask is, do you use AI? And what they're actually saying is, are you tuning an AI model with my data that I own? And what might I need to declare? What might I need to tell either a legal team or a regulatory team? What we're starting to see is, for very sensitive information, companies are moving towards these smaller models. They run them in-house. They might operate them in their walled garden cloud environment, but on a model that they tune, they operate themselves. And that's giving a lot more comfort to larger, highly regulated organizations, particularly for very sensitive information. And it's a very good answer to a regulator to say, we're being very cautious. We've seen that this model performs to this level. If we run it ourselves, it's not a GPT-4, it's a 70 billion parameter model. Here's the evidence of how it performs, and we're keeping it entirely in-house. That's often extremely well received because it demonstrates diligence in the protection of who owns the data, who has the right to exploit it, and where the information goes. It's kept inside the organization as opposed to moving out into the ether, even if it happens to be with a trusted partner. But we're seeing this really interesting evolution because people are suddenly understanding the value of data, particularly unstructured data, to what someone else might create with it should they choose to.
Absolutely. The tagline today, we love data, and that's so important that we're aware of where it's being used. Thank you. Okay, this next question is for Huang, and it's from Surya Chapa. The question is, keeping Steve Bach's talk in mind, how does DPO align with enforcing safety guardrails? Would SMEs be a part of that process in terms of identifying sensitive content?
So my short answer is definitely. I think SMA should always be the part of like the whole greater picture of what you're thinking about toxic or anything that is bad behaviors. Very dependent on generic use cases. You can have the people that do it, but like for enterprises, you need to bankers or like individuals, the employees actually saying that, okay, this is not acceptable. Even a typical workflow like chat response needs to be followed like some workflow adherence from your company. So that's the SMA always has to be the loop. I think the question then comes to how can we make the SMA more efficient? And that's I think where the programmatic approach can come in, where you can instead of like one by one, label at larger scale. So I think, yeah, coming to that question, SMA can definitely always play a role. Coming back to DPO, what you can also do is now because you have a bunch of data you can now, with your SME expertise, generate like which one is bad data, which one is good data, and staying away from bad data. And coming with like the low resource language, because now you have bad data behaviors, you can also translate it and make your model say further away from those bad responses. And that can also steer your like model behavior into a better or ideal, more ideal, like aligned to your enterprise use cases. That's my take.
Thank you, Huang. Continuing on the first half of that question, talking about SMEs, we have one for you, Fred. This is from Faizan Aqil. And his question is, if you're so confident that this skillet works, then why do you even need an SME?
Yeah, that's a great question. Yeah, so I think there's a couple of really interesting places where SMEs really still fit. In general, even if you have like really good access to discovering skills, if these skills are associated with data that's much more specialized, especially in like stuff that's not out there in huge amounts of the internet, reiterating what we were talking about a little bit before, in that case, it's still very invaluable to have an SME help you figure out what exactly are the skills that you're trying to get this model to perform better at. And in addition to that, I think like the other really big thing that people struggle with LLMs is evaluation. And there, even though there's been all this great academic work in terms of using models to automate evaluation, there's this tendency to do a little bit of blind leading the blind in that case. And it's still super invaluable to have an SME to come help you actually figure out what is this model really doing and what is it capable of. And finally, in general, too, a lot of our work in terms of things like Skillet is about having access to a large amount of data. But you still need an SME to come and figure out what the right data is in general for especially very specialized kind of tasks.
Absolutely. Thank you. Talking again about access here, making sure that we really have are connecting between what data we need, who has that knowledge, and getting it into that process. Thank you. All right, our next question is for Trung. This question is from Rachel Gao, and the question is, if the insights obtained from the LLM are biased or incorrect, will it have an unproportionally larger rippling effect to the end task? And how would one alleviate this?
Yeah, that's a great question. I think that when you're kind of evaluating representation models and their usage downstream, you really have to think and map it back to what your downstream task is, right? If you're using these representation models for like classification, it's then really important to identify, are these error modes disproportionately affecting, a certain dimension or a certain class of your data set, right? So it's really important to kind of understand what sort of data distribution you have in terms of your test, how you evaluate, and really kind of iterating back in the model, right? If you see a certain error mode, how can you create the correct data to then retrain your model to correct these errors? So it's a really important insight into where these errors are coming from, what's it impacting, and how to fix them upstream in your model.
Awesome. Thank you for that perspective. Next question is for Chris. This question is from Zihe Wang. How can the SME labeling become more scalable? Is the chunking and building of training data done with traditional Snorkel rule-based label propagation approaches?
Yeah, so that is one of the ways in which we're making their annotation scalable. So the algorithms that we already have in the platform are learning from a small amount of annotations that the SMEs have provided, and it's learning from the logic. We're taking the SME intuitions and putting them into the labeling functions. As intuitions are being applied to other parts, other spans in the document, annotating in similar ways, using the kind of rules-based labeling functions that we already offer. And we're also using synthetic data. So you can actually take an existing part of a document and then synthesize questions that are good for it. And we're also using SME intuitions in the prompts that we use to synthesize those questions that are appropriate for the document sections. So that was the other dominant approach that we used for building up the programmatic data set in the RAG project that I discussed.
Awesome. Thank you. Okay, this is an open floor question, so anyone who wants to jump in here. The question is from Utkarsh Sada, and the question is, what are some good examples, like use cases, of LLMs using function calling?
Maybe I'll start that one because we've got some interesting use cases that we've explored. The fascinating thing with the early phase of RAG was that people treated it like a version of Wikipedia document search over the source information, and they got all of this unstructured response back, and that was useful for a human to consume. But when you want to connect it either to a traditional front end, you might want to extract company information from a document and present it on a screen, or even inject that into the next phase in a program, you need to get structured information that's certainly in a particular format back. So, some of the interesting things that we've explored have been in underwriting data extraction, as we were talking about before. So underwriting processes tend to rely on structured information. How much does this company make? What's their total claim cost been in dollars in the last 5 years? How many user accounts do they have on their systems for cyber insurance? These are all very specific things that, you can't inject a word or a phrase into an Excel spreadsheet that does that calculation. Function calling in this context lets us be certain about what we're going to get back. It's a really interesting thing that you actually see an interplay between this structured information, but also the ability to inject unstructured responses as part of that as well. I was saying before that you might be able to say how many, what was the revenue of this company in the last 12 months, and you get a static integer answer back, but also being able to have a function calling argument where you get to give it a prose-based reason, a plain language reason for why it's made that decision. I've looked at this information, I've added this together, I've performed this. If it doesn't perform correctly, it lets you tune your prompt, it lets you potentially tune the model to improve that quality as well. So, yes, absolutely. If you plan to connect the output of an LLM into a traditional programmatic system, function calling is a superpower, but it's important not to forget the other side as well. Humans are the ones that iterate on the quality of what goes into these structured responses, and you're playing both sides of the coin effectively.
Absolutely. The next question is also open for anyone to jump in here. The question is from Naveen Shukla, and it is, how do you decide whether a challenge requires an LLM or not?
I think it's an awesome one. I mean, I think just taking a step back, a lot of this is kind of just good engineering or I could say data science is really just good engineering practice of kind of setting up workflows that enable you to try simplest approaches first and then progress through empirical guidance to more advanced ones, which, as you can imagine, is also what we try to build at Snorkel, but it's just a general kind of guiding principle. I think the interesting thing, though, is that it gets flipped a little bit with LLMs because of this accessibility principle. Like, if you think about prompting as an interface with a large language, the big generalist model, and Alex, you were kind of talking about this, it really lowers the bar. It's incredibly accessible. It's incredibly interactive in the development loop. It's natural language level accessible even, and especially. So I think there is a kind of pathway where you start with the simplest approach, which is just prompt it, but the biggest heavyweight model. And I think when the dust settles, that's where, by the way, as a side note, where we're going to see most of the usage of these big mega generalist frontier models is the kind of first mile stage. And then, so it is starting simple in terms of just prompt it or zero few shot approaches. Although it is starting with the kind of biggest, heaviest weight model in terms of what's behind the API. But start simple, do some prompting, and then at least how we think about it is, progress to more advanced techniques. So you're progressing simple to advanced, not on the model size, but on the complexity of development operation axis. Start with prompting, then you can employ more advanced prompting techniques if you want. Generally, at some point, you're going to have to segue into fine-tuning the model, then fine-tuning potentially the whole system, including the RAG components, the reward model, if you're doing that kind of preference modeling, et cetera. And then you may then kind of tag on distillation to kind of shrink to a smaller model. So the way that we often see it is, I think a lot of the workflow is actually going to start with the biggest model, and then potentially for most applications, I think actually graduate to the smallest model. So we have these examples. There's a Google case study we did recently where you start with Palm 2, or we did one with Azure, start with GPT-4. By the end of the process, you're at a almost twice as accurate model that's 10,000 times smaller and looks like a traditional one. So again, I think the development experience is simple to advanced. Start with prompting, move to fine-tuning, labeling, distillation, et cetera. But interestingly, the model level approach is going from big to small. And I think we're going to see a lot of that progression in enterprise use cases, especially.
Just as an amusing addition to that, knowing when not to use a language model at all is an interesting insight too. Engineers have a tendency to use one thing for everything. And I saw an example recently where someone got a very complex extractive answer from an LLM. Then they injected it back into the LLM saying, okay, now can you sort this list alphabetically for me? And of course, not using a model at all for that is what the general engineer would choose to do. But when we get these great powers, we're tempted to just use it for everything, regardless if there's a better solution.
It's a great point. I think it does, like, it's education and guidance of, okay, maybe everyone starts with the LLM, and I think that's going to happen, right? But then I think most use cases are going to progress to something else, whether it's a basic sorting algorithm or a smaller model. I think that's the pathway we're going to see for all but a small number of the kind of big generalist applications, which I think is interesting in terms of what it implies for the space and the toolkit.
Thank you. Okay, I always like to wrap up these sessions with a little bit of a lightning round. So I'd love to hear a quick response from each of the speakers here today to our final question. And feel free to keep it brief. The question is, what do you anticipate will be the biggest impact of enterprise AI systems this year?
I guess we should just jump in and then hand it off to someone else. What's the biggest impact of enterprise AI systems this year? Well, I think taking a step back, I think from a business impact perspective, I still think we're at the level for most enterprises where the bar is any, 0 to 1. I think we're heavily and more than most people realize in the demo and innovation lab, mode, and that's the first place. I mean, that's where pretty much everyone in this group lives, and it's super exciting. But it's our job on the research side, the startup side, the innovation team side to kind of get that across the chasm to real business value. So I think our bar as a community should be any, and I think that's going to be harder because of all the problems we've talked about of getting from demo to flashy demo to production. In terms of where it's going to have impact though, and where I'm most optimistic, I think it's going to be. Let me say something a little bit more contrary, and then I will actually shut up and pass the baton. But I think it's going to be less in chatbots and copilots than people think, and more in traditional ML applications. Like, can we extract something from this document, or can we make this decision very well, sped up and built on top of pre-trained models like LLMs? That's my guess. I think there will be a couple of copilot applications code we already see shooting off stuff around marketing and following that heuristic where there's a little bit of a looser spec for what you're putting out. I think there's gonna be a lot more impact in areas that are not just purely chatbots. That's my contrarian take. So in summary, I think let's just get 0 to 1, right? Let's realize we're still in the flashy demo phase in most enterprises. It's critical to keep all the great AI buzz going that we get to real business value. And then number 2, I think there will be chatbots, there will be copilots, but I think people overestimate the value from that and underestimate the value from using LLMs to speed up and accelerate more traditional, model outputs or problem types. Next to Alex, going by my screen.
Fantastic, thank you. I think that we're going to see this evolution from what was 6 months ago even called function calling now to tool using. I think that LLMs as an orchestrator of a model pipeline is going to be a fascinating thing to watch. So, this is where we have the input and output of different models coordinating together to solve for a task. This progressive reasoning between here is a description of a task, now figure out the steps, 1 to 10, using these tools to solve for this problem using this input is a really good articulation of the process that a human being goes through. But a language model or any model knowing which tool to use to solve for a particular problem is something that we're right on the cusp of realizing the power of, and probably until 6 or 7 months ago was just not possible at all. Now that it is, or it might be very soon, we're starting to see some really fascinating capabilities emerge that look like creative reasoning, as I like to call it. And creative reasoning is a great description for a lot of the tasks that we have in the enterprise world, between what comes into your task or your team's tasks and what goes out the other side, and accelerating this with a cooperation of humans and machines, I think is going to be the next evolution of what we see in this space over the next 12 to 24 months.
So I have a really specific and kind of banal prediction to make just based on some things I've seen recently. I wouldn't be surprised if for large companies, internal facing virtual assistants become a lot more common, because especially for employees that like navigating HR websites, they often tend to operate really terribly at large companies as is. So it's a low bar. And also the risk is kind of low from the company's perspective, because if the virtual assistant fails, like not a lot of love is lost, and they can iterate very quickly. You don't have to worry about customers. So I wouldn't be surprised if we actually start to see very kind of practical applications and picking out low-hanging fruit on that front at large companies at least.
Yeah. So for me, something will be exciting for me is seeing a fleet of smaller models actually come into productions. I've been showing the kids for like smaller models that doing actually specialized tasks, and that's like piggyback on like Alex Taylor examples, like one larger one like controlling models, but like a fleet of like smaller specialized one that start doing the task, like different techniques on that, and that's going to become like really optimized for like different purposes. So I think that's the thing I will be looking out for, and we love some examples that are deploying in enterprises.
Looking forward to the fleet. Fred, would you like to go next?
Yeah, definitely. Yeah, so I'm an academic, so this is going to be an especially speculative answer. And I totally agree with Alex that like a good bar is just producing value. I think machine learning in general is amazing at like how it's reversed traditional engineering. Like the hard part is not to get to a demo that sort of is a good prototype. That's super easy now. The hard part is to really actually get value out of that. But like the place where I think there's going to be a real impact is a lot of tasks that have to do with processing data. And these are much more internal facing. So things like data munging, data cleaning, doing all these things for especially diverse kind of data modalities, which can be a challenge for kind of traditional systems. I think there's huge value there. And that's something that can be really used like in the very near future.
I love anchoring on that real value, getting beyond the demo. Thank you. Last but not least, Trung.
Yeah, so I think my answer is a little bit similar to some of the prior points. I think that really gaining value for enterprise use cases, I think that, a lot of people have been wowed by like the really amazing demos that have been seen out there with LLMs, but when they're adapting it to their specific data sets, they've seen less amazing results, right? So I think there is going to be a lot of emphasis on quality data in terms of, a lot of enterprises have a lot of data, and really, how do we kind of clean it? What data operations can we use to clean, to construct the right data sets to solve their problem? I think that'll have a higher impact or a larger emphasis in the next year.
Awesome. Thank you all so much for your time. Thank you to these speakers for preparing and coming and answering our questions. And thank you to everyone in the audience for tuning in today. Big thank you for those who came live to answer questions.